Okay, so this is the lesson from the second day of Unit 2. So we do have a warm-up here. You should pause the video and try to do the warm-up and then play to check your answers. Okay, so solving the system, hopefully you notice that the third equation does not have a y, so probably the easiest approach would be, I just did that, probably the easiest approach would be to eliminate the y in the first two equations. If we pair them up, that way we'll have the same variable eliminated. So let's eliminate the y. So if I'm eliminating the y, I probably want to multiply this first equation by 2. So that's going to give me a 6x plus 4y plus 2z is equal to 14. And then the second equation, 2x minus 4y plus z is equal to -4. So when I add those, I'm getting 8x plus 3z is equal to 10. So now I'm going to combine that with my x plus 3z equals 17. So I'm seeing the 3z looks like it'd be easy for us to eliminate the z's. So I'm going to multiply through by -1. So I have negative x minus 3z is equal to -17. So when I combine 8x minus x, I'm getting 7x. The z's are now gone, and that is 10 minus 17, which is -7, which means x is equal to -1. So I'm going to substitute that back in here. So -1 plus 3z is equal to 17, which means 3z is equal to, I'm adding 1, so 18, which means z is equal to 6. So now I'm going to go ahead and get the y. So I'll just go back to the top equation. 3 times -1 plus 2 times y plus z, which is 6, should equal 7. So -3 plus 2y plus 6 equals 7. So 6 minus 3 is 3. 2y plus 3 equals 7, which means 2y is equal to 4, which means y is equal to 2. So as a coordinate point, we have -1, 2, 6. Okay, so today we took a look at word problems, and you want to make sure and get this word problem in your notes. So then what I suggested is that to figure out how to come up with your variables, you should always look to the question you're being asked. So my unknowns, or what I'm being asked, is to find the 3 numbers. So not only do I know that I'm going to make my variables the numbers that I'm looking for, but I also know how many variables to use because there are 3 numbers that are mentioned in the problem. So that's how I know that there will be 3 variables. So I'm going to use x, y, and z to represent the first number, the second number, and the third number. And again, you'll always look to the question. That'll tell you what you should use for your variables because that's the unknowns, and then specifically how many variables to set up because however many unknowns there are. So this particular one does have 3 different unknowns, 3 different variables. So I'm going to read the first statement and translate that into an equation. I see the sum of 3 numbers is 8. Then 3 numbers are x, y, and z, which means x plus y plus z is equal to 8. The second statement says the first number is the sum of the second and the third. So the first number is x is equals the sum of the second and the third. Well, the second and the third are y and z, and sum means add. And the last statement, the third number is twice the first number. Well, the third number is z. So z is equals twice the first number. So I'm going to take the first number, x, and I'm going to multiply by 2. So those are my 3 equations with my 3 variables. Now, looking at this system, we do have 3 equations, but each equation does not have 3 variables. So it's a little bit different than yesterday when we solved systems of equations, 3 equations with 3 variables each. Remember the approach we took there. We paired up, eliminated, and eliminated a third time. I don't think we're going to have to do that here because we don't have 3 variables in each of the 3 equations. So instead of pairing up and using elimination, I believe we can use substitution here. Now, there are multiple different ways of doing this, multiple ways of substituting in from one equation to the other. So I'm just going to show one approach, but what you want to try to do when you're substituting is to substitute so that you can get rid of as many variables as possible. So when I look at the first 2 equations, I immediately notice that y plus z is in both. So what I will do is I will substitute in to the top equation for y plus z. Since they both have y plus z and we know y plus z equals x, then it would be true for me to say that y plus z, I'm going to replace that with x because x does equal y plus z. And in my substituting x in for y plus z, that actually worked out pretty nicely because I just eliminated 2 variables. Y and z are now out of the problem in literally one step. Okay, so that's probably the easiest way to substitute. Again, it doesn't have to go that way. I could have, maybe some of you saw 2x, I could substitute that in for z. True, I could, but then I still would have 2 variables in that equation. I could have substituted in y plus z in for x into the first equation. But again, I'd still have 2 y's and 2 z's then in that first equation. So I'd still have 2 variables. So I think the most efficient use of our substitution would be to substitute x into the first equation where y plus z was. And again, that's because I noticed that they had both equations 1 and 2 had y plus z in common. So when I do that, now I have x plus x, which equals 8. So we know 2x equals 8, which means that x equals 4. Okay, again, if you didn't notice that, you could have substituted something else in and it just would have been a few more steps until you had your first variable. Now we're on to our second variable. Z is 2x, so that means z is 2 times 4, which is 8. And now we're ready to go back to either the second or the first equation. It doesn't really matter to get our third variable of y. So I think I'll go back to the second. X, which is 4, is equal to y plus z, we just said is 8. So y is equal to, subtracting 8 gives me negative 4. So the first number is 4. The second number is negative 4. And the third number is 8. Okay, now we're going to focus on this problem. So go ahead and get that copied into your notes. Okay, so once again, we'll start by defining our variables, and that should help us come up with the equations. So the question being asked of us is, how much was borrowed at each rate? So if that's what's being asked, that's also our unknown, which means that those will be our variables. So we're going to let x equal, and now I have to see, well, what was mentioned in the problem about the different rates. So I see 3 different rates mentioned, which means the amount borrowed at each of those rates is going to be our variables, and that means we're going to have 3 variables in this one. So we're going to let x equal the amount, and when they're talking about amount, they're talking about money. So the amount in dollars borrowed at 8%. And I'm just going in order that they're mentioned in the problem. It doesn't have to necessarily go in that order. When you're defining your variables, be as specific as possible. Don't just say let x equals 8%. Well, what about 8%? It's the amount of money that's borrowed at 8%. Okay, and then y is going to be the next rate, which is 9%. And again, it's not 9% though, it's the amount of money borrowed at 9%. So I'm just going to use quotes here because it's the same thing. The amount of money borrowed at 9%. And lastly, z is the third rate mentioned. Again, the money borrowed at that rate. So the amount of money borrowed at 10% will be z. So if you know how loans work, or if you don't know, I'm going to explain that. So we're going to borrow some money. So parents are borrowing $30,000. Well, they have to pay that money back, and when they pay it back, they have to pay interest on it. Interest means they're going to pay more than what they borrowed. So if they borrowed a certain amount of money at 8%, well, they're going to have to figure out the interest that they have to pay for that amount of money that they borrowed. So to do that, they'll take 8% of however much money was borrowed at that rate. And in order to do that, we know that we can just multiply 0.08 by that amount. Well, we just said that that amount that they borrowed at 8% is x. And we just said we're going to take that amount times 0.08. So I think we're starting to come up with an equation here. 0.08 times x. That will represent the interest that they'll pay for the amount that they borrowed at 8%. So now let's get the interest that they're going to pay for the amount that they borrowed at 9%. Well, 9% of the amount they borrowed is y. So we're going to take 0.09 times y. And lastly, they borrowed some at 10%. So to figure out the interest, we'll take 10% of the amount they borrowed at 10%, which is z. So 0.1 times z. So if the 0.08x represents the interest for the amount they borrowed at 8%, and the 0.09y represents the interest that they owe for the amount they borrowed at 9%, and the 0.1z represents the interest that they owe for the amount they borrowed at 10%, I want a total amount of interest. So I'm going to add those three interests together, and I know that the total should equal that 2,600. Now, I also know that the total amount borrowed is $30,000. Well, we have amount borrowed x, amount borrowed y, amount borrowed z. So I know to get a total, I'm going to add those three. So x plus y plus z. And that total amount borrowed is $30,000. So that's our second equation. Now, the last thing mentioned that we have not used yet is the amount borrowed at 9% was twice the amount borrowed at 10%. So 9%, the amount borrowed is our y, and 10% is the amount borrowed at, which is our z. So twice the 10, so twice the z, is equal to the amount borrowed at 9%, which was our y. So y is equal to 2z. So now I'm looking at this system of equations and I'm trying to decide how I want to solve it. Well, the first two equations have the x, the y, and the z together, so all three variables. The third equation does not have an x. So what I'm thinking is, this one's kind of maybe like the warm-up, I should eliminate using the first two equations, pair up the first two, and eliminate the same variable that was eliminated in the third, which is x. So I'm going to do that. I'm going to pair up the first two, eliminate x, and then I'll have two equations that don't have an x. And then I'll go from there. So if I'm eliminating the x, first of all, I want to get rid of these decimals. So we talked about that a week or so ago, how we get rid of the decimals that are in that are currently showing in hundredths place. We're going to multiply by 100. So if I just scroll down here a little bit. So if I multiply 100 times this first equation, let's see what we're going to get here. So we know 2 decimal places to the right gives us 8x, plus 2 decimal places to the right gives us 9y, and 2 decimal places to the right gives us 10z. And then I'm just going to add 2 zeros on to the 2,600, which gives me 260,000. So that's the first equation times 100. Then the second equation, I have x plus y plus z equals 30,000. Well, we already said we want to eliminate the x's. So if I have an 8x from the first equation and I want to eliminate the x and I have a 1x in the second equation, I know that I'm going to multiply through here by negative 8. So negative 8 times x, negative 8x, negative 8y, negative 8z equals, well, negative 8 times 3 is negative 24. And then I'll just add all those zeros. So we have negative 240,000. So now I can combine those and eliminate my x's. So I have 9y minus 8y, which is 1y. I have 10z minus 8z, which is 2z. And I have 260,000 minus 240,000, which is 20,000. So now I'm going to, well, I'm looking here, I have y plus 2z equals 20,000, and I have y equals 2z. That's the other equation I haven't used yet. So I have a couple options. I could, in this equation here, I could subtract 2z, and then I'd have it in the same format that I have this equation in, and then I could eliminate. Or probably even easier would be just to substitute 2z in for y into this equation, okay, which is what I'm going to do. So 2z plus another 2z is equal to 20,000, which means 4z is 20,000, which means that z is 5,000. So now that we have z, let's go ahead and get y. Well, y is 2z, which means 10,000. Okay, and we'll put the dollar sign on here in a minute when we answer the question. And lastly, it looks like we still need x. So let's go back to our x plus y plus z equals 30,000. So x we don't know, plus y we just got, 10,000, plus z, 5,000, should equal 30,000. So we have x plus 15,000 should equal 30,000. So if I subtract 15,000 from each side, I'm getting x is 15,000. Okay. So now let's answer our question. So the amount borrowed at 8% is X, which is $15,000. At 9% is Y, which we said was $10,000. And at 10% is Z, which we said is $5,000. And that's it. Okay, so with this one, we didn't do strictly all substitution, and the reason we did not was because at the beginning here, we had two equations that had 3 variables each. So we did pair those up and eliminate, and what we eliminated was the X because we noticed the third equation, which didn't have the 3 variables, it didn't have an X. So we purposely eliminated the X so that we would then have 2 equations that both didn't have an X. So then when we go to solve, after we did that first step of eliminating the X, we could have either substituted in, which is what we did, the 2z into our equation here for y, or we could have brought the 2z over to the other side and then eliminated y plus 2z equals 20,000 and y minus 2z equals 0, and we could have eliminated that way. Either way, we ended up with our variable, and then we just did a process of substitution to get the other variables. Okay. So that's it for notes for today. Homework is in Unit 2, Worksheet number 1, problems 2 through 12. Work on those for tomorrow.